Good day once again. Welcome to today's class on applications of stoichiometry. We want to see one of the applications of stoichiometry, that is, we want to use the knowledge you have grasped from the topic stoichiometry and see how we can solve problems on chemistry involving stoichiometric equation. Remember, the stoichiometric equation must be a well-balanced equation, and we have a problem before us this evening to discuss. Calculate the percentage of vitamin C in the tablet. Calculate the percentage of carbon in the vitamin C content of the tablet. Now, what you say is that they say the tablet contains vitamin C. That is possibly to be called vitamin C tablet. So, since they say it contains vitamin C, say vitamin C is inside the tablet plus other ingredients. And this is what we call in pharmacy, this other ingredient, what we call SCPS. That means that the tablet of vitamin C contains the vitamin C itself plus other SCPS, other ingredients, which includes binder, disintegrants, color, and all have you, if you want to talk about colored vitamin C. So, in this question, we can calculate vitamin C content and we can calculate what other ingredients. Let's see. Now we have two equations. We have to check if the equations are well balanced. Carbon 6, hydrogen 8, oxygen 6, bromine 2. This is balanced. This is hydrogen 1 plus 1, 2, hydrogen 2, bromine 1, bromine 2, sodium 1, oxygen 1. The other one is also balanced. So we can comfortably say that these are well-balanced stoichiometric equation. Then next thing we have to do is that we ask ourselves, what value do we have here? We are given the value of total tablet, which is vitamin C plus other ingredients. And we are also given the value of molar conc, the concentration of sodium hydroxide, 40 cm³ of that sodium hydroxide. We are given the concentration. So what we do is that we have to get the number of sodium hydroxide that went into reaction here. Because here we didn't see sodium hydroxide. We'll talk about it here. Number of sodium hydroxide that reacted here. Let's get it. You say number of moles of sodium hydroxide that reacted is equals to molar conc times the molar concentration of it times volume given all over 1000. The molar concentration is 0.145. The volume is 40 all over 1000. You press it in your calculator. Everything will be giving you 0.0058 cm³. So this is 0.0058 moles, because it's a number of moles, please, not cm³, mole. Now we have realized that the number of moles of this that will react is what? 0.058 mole. Now this HBr is in the ratio of 1:1 with this. This is 1 HBr, 1 sodium hydroxide. That means because they are in ratio of 1:1, this one will also be 0.058 mole. Okay, because they are in ratio of 1:1. 0.0058 mole will give you also 0.058 mole because they are 1:1. 0.0058 mole, please. Now we have gotten the number of moles of HBr that should react with this in the ratio of 1:1. We take this 0.0 and take it to this equation which has HBr 0.0058 mole. Now it is important to know that this is in the ratio of 2:1. There is invisible 1 here for this vitamin C, 2:1. So if we have 0.0058 moles, comparing it with this, that 1 of vitamin C, 1 mole of vitamin C produce what? 2 mole of what? HBr. Therefore 0.005 mole of HBr will be giving you how many vitamin C? This times 1 divided by 2, 0.0029 mole. So we say here is 0.0029 mole. We have gotten the number of moles of vitamin C that should go into reaction considering this or using this well balanced stoichiometric equation. Now the next thing we have to do is you now say, okay, let me get the mass of vitamin C that should go into reaction. For you to get the mass that should go into reaction, you use the number of moles that went into reaction and say mass of vitamin C equal to its number of mole times its molar mass. And you know that molar mass is gram per mole, right? A number of mole is a mole. Now let's get the molar mass of vitamin C. Carbon was given to be 12. 12 times 6, that is 72, plus hydrogen was given to be what? 1. That is atomic mass is 1. 1 times 8, 8. Then oxygen, the atomic mass is 16. 16 times 6, 96. That will be giving us 176 gram per mole. So we now say 0.0029 times 176 gram per mole. What will it give us? Okay, 0.0029 times 176. That will be giving us 0.5104 grams. 0.5104 grams. Let's write it clearly. It will give you 0.5104 grams. Now, to convert this gram to milligram, they have a relationship. If you want to convert gram to milligram, what you do is that you multiply the gram given to you by 1000. You want to convert gram to milligram, multiply the gram given to you by 1000. So this is 510 milligram. Because if I multiply this by 1000, 1, 2, 3, it will give me this. This is the mass of vitamin C that should be inside that tablet. Remember, the tablet fully is 550. That means here is 510.4 milligram, and the total is what? 550 milligram. If they say find the mass of other ingredients, you see you can get it, because 510 plus something will give you 550. You just subtract. That is something you have to do. 550 minus 510.4. That will be giving you 39.6 milligram. That means the vitamin C content of that tablet we are talking about is 510.4 milligram, whereas other ingredients is 39.6 milligram, whereas the total it will produce, the total tablet it will produce is 550 milligram, because this plus this will be giving you 550 milligram. So we have sorted this now, but the question is calculate the percentage of vitamin C in the tablet. Calculate the percentage of vitamin C in the tablet. What is the mass of vitamin C in the tablet? 510. What is the total mass? 550. Now percentage. Let's get the percentage. Percentage is equal to mass of vitamin C, percentage of vitamin C equal to mass of vitamin C all over total mass times 100/1. What is the mass of vitamin C? 510.4. What is the total mass? 550 times 100/1. Let's check. So we now have 5.4 divided by 550. So that will be giving us 92.8%. That is a percentage of vitamin C in the tablet, and we say it by saying mass of vitamin C all over total mass times 100/1. If they ask us calculate the percentage of other ingredients which are not vitamin C in the tablet, what we say is mass of other ingredients all over the total mass 550 times 100/1. That means that one will be, or once you have gotten this, minus it from what? 100. That will be giving me 7.2%. The percentage of vitamin C content, minus it from the total percentage, which is 100, you get the percentage of other ingredients. Or you follow the same formula that says 39.6 all over 550 times 100/1. The two approaches will give you the same answer. 39.6 divided by 550. That is the same. That is correct. Okay, we have solved question number A. B says calculate the percentage of carbon in the vitamin C content of the tablet. Let's see how to calculate it. For you to calculate the percentage of carbon in the vitamin C content of the tablet, all you need to do first, in vitamin C, how many carbon does it have? 6 carbon. An atomic mass of carbon is 12. 12 times 6 will give you what? You say the formula is molar mass of carbon of the carbon 6 all over total molar mass. Total molar mass times molar mass of the over total molar mass. What is the quantity of vitamin C? 510 times 510.4, so that we get the amount of carbon is inside this word vitamin C. The vitamin C is 510.4. We want to get the amount of carbon inside this, and that will be giving us 6 times 12, 72 all over 176 times 510.4. 72 divided by 176 times what? 510.4. That will be giving us 208.8 milligram. That means the quantity of carbon, the mass of carbon inside this 510.4 milligram of vitamin C is this. This is the quantity of carbon inside it. Then for us to calculate the percentage of carbon in the vitamin C, we said, you say what is the quantity of carbon in the vitamin C all over what is the total vitamin C. What is the total vitamin C, not what is the total tablet. What is the total vitamin C? This times 100/1. So divided by 510.4. So that will be giving us 40.9%. So that is the answer to question number 2. You can see that it's possible to use the knowledge you have from stoichiometry. You can see you can use it to solve any problems on chemistry involving well-balanced stoichiometric equation. Unless the equation is not well balanced, then you can't apply it. So we have seen how you can solve this problem. Thank you once again for watching today's video.